As SpaceX prepares for its historic IPO, a quiet tension hums beneath the surface of financial markets. Investors are quietly redefining what this space company truly means. The market isn't pricing SpaceX as just another rocket manufacturer. It's framing the upcoming public offering as a strategic bet on the next layer of artificial intelligence infrastructure. Why? Because SpaceX's constellation of satellites isn't just launching payloads. It's building the low-latency, global data highways that could fundamentally reshape how AI systems process information across continents. This isn't about rockets flying to orbit. It's about the invisible networks that will move the raw data fueling tomorrow's intelligence, turning space into the critical backbone for real-time AI decision-making before the world even realizes it. In the race to build smarter AI systems, there's a fundamental gap between the digital models we create and the physical world they must interact with. While most companies focus on training vast neural networks, the real bottleneck lies in the seamless, real-time flow of data between AI systems and the billions of sensors, devices, and human interactions that generate it. SpaceX's Starlink constellation isn't about rockets or spaceflight. It's about constructing the global backbone that moves petabytes of raw data across continents with near-instant latency. This isn't just about connectivity. It's about creating the essential infrastructure layer that turns theoretical AI potential into actionable intelligence, making the missing piece critical for AI to truly scale beyond the lab and serve society at its full capacity. We've seen AI models promised with dazzling speed and scale, yet the quiet, physical infrastructure that makes them truly operational remains the most overlooked pillar. This isn't just about servers or cloud services. It's about the real-world networks, data pipelines, and edge systems that connect AI to tangible reality. When SpaceX launches satellites into low Earth orbit, they don't just build rockets. They create the global infrastructure that feeds AI with real-time Earth data. Without this foundational layer, this physical backbone, the theoretical power of AI becomes irrelevant. The next big shift in AI isn't about the algorithms themselves, but about who controls the infrastructure that turns those algorithms into something that actually moves the world. That's the sober reality we're witnessing now. Picture this. As AI systems race to process real-time data across vast distances, SpaceX's Starlink network emerges as a critical new layer in the infrastructure stack. Unlike terrestrial networks constrained by physical infrastructure, Starlink's constellation of satellites delivers global coverage with latency measured in milliseconds, far below the seconds typical of ground-based systems. This precision becomes essential for distributed AI training, where massive datasets must flow instantly between edge devices and cloud servers. For applications demanding immediate responses, like autonomous vehicles navigating complex environments or industrial IoT systems adjusting machinery in real time, Starlink's ability to bypass traditional bottlenecks transforms the entire data pipeline. In the race to build the next generation of intelligent systems, this satellite network isn't just a connection point. It's the foundational backbone enabling AI to function at scale where terrestrial networks fall short. Starlink's operational reality gives SpaceX something more tangible than a future-facing AI story. A satellite internet business with real customers, recurring demand, and a global infrastructure footprint. This is the part of the thesis that is not just imagination. At the same time, SpaceX's launch services show operational depth through government, commercial, and strategic demand for access to orbit. Together, those businesses create the foundation investors can actually study before they consider the more speculative AI infrastructure case. The important distinction is simple. Proven connectivity and launch operations belong in one column. Future claims about space-based AI infrastructure belong in another. A serious educational look at the IPO has to keep those columns separate, because that is where hype becomes analysis. As AI systems demand ever more distributed computing power and real-time edge connectivity, the next critical frontier for infrastructure isn't on Earth, but in the void above us. SpaceX's upcoming IPO represents more than just a stock market event. It signals an urgent shift towards space-based solutions that could become the backbone of AI's data movement. Terrestrial networks struggle with latency when handling massive real-world applications like autonomous vehicle decision-making or global climate modeling, requiring instant, seamless data flow across continents. By deploying constellations of satellites, SpaceX aims to solve this bottleneck, enabling AI models to process information with near-instantaneous speed across the planet. This isn't about current revenue streams, but about securing the foundational infrastructure that will power AI's next wave of innovation, before competitors lock in the future. The stakes are high, the timeline is tight, and space isn't just the next frontier. It's the only viable path for AI to scale truly globally. When SpaceX prepares for its public market debut, the valuation hinges on a far more profound shift than just rocket launches. This isn't about orbital deployment anymore. It's about the quiet infrastructure powering tomorrow's AI. The market is pricing SpaceX's value through the lens of its ability to build the global data highways that move petabytes of machine learning workloads between continents. Think satellite constellations stitching together real-time data streams for AI models, not just launching payloads. Investors are betting that SpaceX's network will become the essential backbone for training the next generation of artificial intelligence, transforming how data moves across the planet. This valuation isn't a simple reflection of current earnings, but a high-stakes gamble on whether space infrastructure can reliably support the massive, growing demand for AI's computational needs. The market's belief here carries profound risk, yet it's the only way to truly understand SpaceX's next chapter. AI systems are rapidly demanding seamless global connectivity for real-time distributed computing and edge applications, yet current terrestrial networks struggle with latency and coverage gaps in remote regions, disaster zones, or even space. SpaceX's Starlink offers a transformative solution by providing ultra-low latency, high-bandwidth links directly from orbit, enabling AI models to process data instantly across vast distances without traditional infrastructure bottlenecks. Imagine satellite networks powering real-time video analysis in conflict zones, predicting climate shifts from sparse sensor data, or training models in isolated communities where terrestrial internet fails. This isn't just about faster connections. It's about making AI truly accessible where it matters most. SpaceX's unique capability to deploy this network at scale positions them to become the critical backbone for the next wave of intelligent systems, turning AI's potential into a brighter, more inclusive future for all. SpaceX's capital firehose, billions poured into Starlink and Starship, hasn't yet found its revenue engine, creating a stark tension for investors. The company's aggressive spending on launches and satellite networks, while ambitious, risks leaving the AI infrastructure dream unprofitable for years. Regulatory hurdles? They're not just obstacles. They're a gauntlet that could delay the full realization of SpaceX's AI potential by years. Without clear, near-term revenue streams from AI applications, the market might overprice this entire infrastructure play, pricing in unrealistic expectations. That's where the bear case shines. If the regulatory path remains tangled and the revenue pipeline stays dry, the market could trigger a sharp correction. The stakes? Realizing the AI infrastructure potential without the capital return or regulatory clearance simply isn't happening yet. Investors face a critical tension as SpaceX prepares for its public market debut. How deeply is the company's future growth fundamentally anchored to artificial intelligence infrastructure? Starlink's global, low-latency network isn't just a satellite service. It's a potential backbone for AI systems demanding real-time data pipelines. Can this constellation scale to handle the exploding compute-intensive tasks of next-generation neural networks without triggering unsustainable costs? The answer hinges on whether AI applications, particularly those requiring millisecond responses for training or inference, will surge to levels that make Starlink's unique advantages economically viable. If AI demand accelerates exponentially, SpaceX could evolve into an indispensable infrastructure layer for the digital age. But without that specific AI appetite driving network utilization, the entire investment risks becoming a costly, unconnected asset in a rapidly shifting tech landscape. When we talk about the next wave of AI winners, the real story isn't just about the models themselves, but the invisible infrastructure that powers them. SpaceX isn't just a launch company. It's building the global data highways that move petabytes across continents. That low-cost satellite network is the backbone enabling AI to see the world in real time, from weather forecasting to disaster response. But here's the crucial shift. True winners won't be the ones chasing hype. They'll be the companies that build this infrastructure and profit from it sustainably. Without that financial discipline, without turning rockets into reliable revenue streams, these systems risk collapsing into fleeting speculation. The next big play isn't in the code. It's in the rockets that keep the data flowing. That's where real, lasting growth begins. AI systems today face a critical vulnerability. Their ability to process data efficiently collapses when terrestrial networks falter. This isn't just a technical limitation, it's a practical constraint that undermines real-world applications. Consider disaster zones where infrastructure fails, or remote regions where signals vanish. Traditional internet struggles to deliver the low-latency, resilient data flow AI demands for timely decisions. SpaceX's orbital network offers a potential solution by providing a globally interconnected layer that bypasses terrestrial weaknesses. For AI to scale beyond local constraints, especially in emergency response, space operations, or resource-limited environments, this kind of reliable, high-speed data pipeline becomes non-negotiable. Without it, the promise of truly global AI remains confined to theoretical possibilities. You've heard the buzz. The market's chasing SpaceX as the next AI powerhouse, betting big on its potential to revolutionize artificial intelligence. But investors are watching the numbers tell a different story. The company's current revenue streams are firmly rooted in launch services and Starlink's satellite internet, not yet in any AI-driven applications. There's zero revenue generated from AI infrastructure, and the transition from today's operations to meaningful AI applications remains raw, unfinished work. This isn't just a gap, it's a crack in the foundation between what the market claims and what SpaceX actually delivers. That chasm explains why investors must tread carefully. The hype could easily lead to overpaying for potential that hasn't even begun to materialize. As SpaceX prepares for its potential public market entry, investors must closely track three critical pressures: whether Starlink can expand its global network without draining the company's financial reserves, the tangible progress on Starship's complex orbital capabilities, and how evolving regulatory frameworks respond to SpaceX's unprecedented role in building critical infrastructure. The market's growing belief in SpaceX as the next major AI infrastructure player hinges entirely on these dynamics. If Starlink's rapid scaling strains operational capacity, if Starship development faces repeated regulatory delays or technical hurdles, or if authorities impose stricter oversight on the company's expanding influence, the entire valuation could unravel. Such failures would trigger significant investor losses, demonstrating that the path to becoming a foundational AI enabler requires more than just technical ambition. It demands disciplined resource management and regulatory alignment to avoid catastrophic market consequences. When we talk about the next big AI play, the real story isn't about training the next massive model, but about building the invisible networks that move data across the globe, real infrastructure that turns AI from theoretical potential into practical reality. This isn't just about fiber optics or data centers. It's about the orbital constellations SpaceX is deploying, the satellite networks that bridge continents with near-instant latency. For AI to function beyond the lab, like guiding autonomous vehicles or predicting climate shifts, it needs this foundation: the ability to move data where it matters when it matters. The lesson is stark. Infrastructure must be built with financial discipline. Without it, we risk creating a speculative bubble where the sky becomes the limit, but the foundation crumbles. This is where true infrastructure plays out.